Okay, so now I really want to. Any other questions? Right? So I'm not expecting you to get a very clear picture from this explanation, like it's basically I'm using my fingers to show you, okay, here's something in memory, here's something else. But there is a mechanism that is responsible for making sure that this dynamic behavior does take place at runtime. Right? Because at some point here, I can also essentially modify one of the drawings and create another object in place, and still this dynamic hidden data member of the shape will help us to make sure that we will be talking to the methods of that object. So anyway. But another interesting piece is that the methods do not take space when we create objects. The methods are compiled and they're part of our program. They're all sitting in their unique addresses, but the methods do not contribute to the size of our object. The size of our object is determined only by how much data it contains, not how many methods we added to our class. All methods are separately stored in memory, and they're called, but they're not called based on what is present inside of our objects. When we use object references, those guys are designed to point to our classes, and they're it basically at compile time, the methods are wired to these particular types of objects. So, it's important to understand that all data, including our objects, is separate from any methods. All methods are also in memory, but they have nothing to do with the sizes of our objects or any memory real estate occupied by our objects. So it's just something that sort of like that we need to be aware of when we write our code. So adding new data members to our classes is a concern for the size of our program at runtime, how much memory is going to be needed. Because imagine if I have, I don't know, this high resolution on my screen, and I create those thousands of pixels. If I add just one single integer to one of the, to the definition of class name pixel, this may, increase the size of my program at runtime by megabytes, right? Just one integer added to a class name pixel. Because if I create, hundreds of thousands of them, each integer, if I added it to my pixel, will contribute great deal after all, if you count it all. Right? However, if I add new methods to my pixel, that makes no impact on the size of my object at runtime, because all methods are compiled separately and they're completely sidelined from our objects. So that's just something that we need to be aware of as programmers, because we want to be efficient. We want to write efficient code, so that we're in control how efficient what we do is. And that includes, of course, memory management. By the way, from this perspective, a lot of scholars, who do research in programming languages and overall computing, they would tell you that object-oriented programming really is an attempt to manage memory based on object-oriented principles. Because everything that we do with objects, really, they don't change much how program works. Because all programs basically method call after method call after method call. But what really changes with object-oriented principles of structuring programs is how we organize memory, right? Because everything that we do with our data and give our data to our objects is really how we begin to manage individual pieces of memory based on how many objects we create, how big they are, and all these details about them. But the executable code is still the same as in procedural programming. It's all procedures after all when the program starts to execute. So an interesting set of aspects here. So what else I would like to talk about? Now I'd like to essentially leverage this by the way, before I forget this, I would just say that if you take a look at this line of code, where we said, okay, inside the loop, let's find all of our elements, circles and rectangles. We could also create the triangle class and add its own formula to compute the area and all that, right? So we could have a lot of individual objects. So, but we found a way to uniformly access each one of them and say get area, and accumulated the total area, and we're able to display it. So, but I'd like to note that get area is the call that doesn't modify the state of any objects, right? It's like a read-only. Okay, give me your height and width, multiply it and give me the result, right? But the height and width doesn't change, right? If get area method call would be changing anything inside of our classes, that would be pretty bad design, right? No one would expect it to make program like that manageable. So this is in a way an immutable call, something that so get area uniformly doesn't change the state of any of our objects. So that's kind of good. It's safe, and so it's effective. So what I'd like to tell you that many times when there's this immutable read-only access to collection, and like what we just did, we're trying to access everything there. Many people would actually try this version of the for loop, and just another place where we can try it. Basically say shape for all shapes in drawing, which is the name of our array. You just say total area. I will rewrite this. So this time you can say shape get area. So in this way we don't need index or any of this coding. So arguably this is a better approach to iterate through all elements in our collection and make those simple calls. So look what happens here. We say, all right, we know we have an array of shapes. So this is the name of our array, drawing, right? And then we say, all right, shape. If we say shape like this, like I did, this name of variable shape becomes a reference to a shape, right? Very much like what we have inside of our array. Each element of our array is not a real object. It's only a pointer, what we call object reference to a real object created by new. So therefore, if I say shape like I just did over there, I'm creating a temporary reference, and so this syntax allows to iterate through the entire collection, and each time inside the loop, shape will be referring to 0, 1, 2, 3, and so forth all the way through. So this is nowadays this is one of the latest constructs added to Java specification, and it became very popular with Java programmers to an extent that C++ design committee decided, oh, we want this type of iteration, this construct in the C++ programming language. And so Java sort of like contributed to the design of the latest version of C++. The C++ people said, this is so neat and so clear that we want the syntax to be in C++ as well. So very popular structure, just to let you know that perhaps this would be a better version of what we just coded. All right, so